A wonderful good morning, ladies and gentlemen. I welcome you here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries. This year in 2015 at the Hanover Fairground. Every 15 minutes I invite you to enjoy interesting presentations regarding the hydrogen industry. My first topic will be compressing hydrogen without any moving parts, thermal metal hydride H2 compressor. And for that, please welcome with me on stage our first speaker of the day, Marketing and Sales Manager at Hystorsis, Mr. Jon Björn Skulason. Big hand, please.
Thank you very much and good morning. I'm going to talk about compressing hydrogen without any moving parts, which is a new technology on utilizing metal hydride compressors. So we lost the slides for a... So if we look at Hystorsis at a glance, our main competence has been R&D work for quite many years. We've been working on R&D since 2008. Looking at metal hydride characteristics. We're looking at the utilization, synthesis and optimizing modification, and in general hydrogen technology, system comprehension, system integration, and then compression and storage of hydrogen. And the compression part has been our core activity over the last few years, but we're also working on a metal hydride storage unit. If we look at the new compressor we have built, the design criteria for the compressor was to have a size of somewhere between 0.5 cubic meters an hour up to about 50 cubic meters an hour, and to compress hydrogen from roughly 1 bar up to 250 bars. We have done this work a lot with our Norwegian partners, specifically in the Institute for Energy Technology, where actually our offices are based, Prototech. And these players have been working on metal hydrides for quite many years, and there's a lot of know-how. So as you can see here, we call our compressor HYMEC, or a hydrogen metal hydride compressor, and the number represents the quantity of hydrogen you can compress. And the picture here actually shows a compressor taking hydrogen from 10 bars to 200 bars. If we look at how the system works and the key features, actually we have a much higher content of hydrogen inside the vessel if we have metal hydrides. So if we look at inside the cylinders of the compressor, you can see that it's filled with metal hydride powder. And I'm not going to go into any details of actually how this works, but you can see how the gas is stored in the solid metal. And then I'll explain the technology. So what we have low pressure hydrogen coming to the cylinder. While the hydrogen is flowing to the cylinder, we apply cooling. And after filling the cylinder up, we heat up the cylinder. And after heating the cylinder up, we actually have high pressure hydrogen coming out. So it's a relatively simple process. We need roughly a temperature ratio of at least 70 degrees to actually raise the pressure of the hydrogen. And in a sense, the higher temperature ratio we have inside the cylinder, we have a higher compression ratio of hydrogen. So if the temperature difference is 120 degrees, 150 degrees, the ratio of compression is much higher. The heat transfer fluid can be very different. We can use many different types of fluids. We could use water, superheated water, oil. We can use steam, geothermal water, or other applications. So any type of hot fluids we can actually utilize inside the cylinders with the metal hydrides to heat up. With a metal hydride compressor, you have a lot of unique features which you don't find in other compressors. With almost no moving parts, like in the piston compressors, we have a very low maintenance cost and of course a very high safety record. It's a very silent operation. There's almost no moving part and there's no vibration. It has a very flexible installation, so in a sense we can design it for different types of customers. It doesn't have to have the configuration we have already built it in. You could have it wall mounted or any way that the customer would like to have it. We guarantee very, very high gas purity because in a sense when the gas enters the metal hydride, all impurities are trapped in the metal powder. Of course it's better to have as pure hydrogen coming in as you want, but at least the customer can be guaranteed that the hydrogen coming out is at the extremely high purity. It's a scalable solution, so we can build it to customer needs, as I said earlier, from any sizes, roughly around 0.5 cubic meters an hour, up to about 50, or we at least haven't looked much above 50 cubic meters an hour. And as I say, if you have waste heat available, for example, from industries, hot water, geothermal source, or anything, there is almost no energy cost whatsoever. The only electricity we would need is to move a handful of valves. So the electricity consumption of the compressor is almost zero. So the best and the niche market which we are looking into is actually where you have available waste heat, geothermal source, or any other sources of hot. We revealed our compressor on May 28th, 2013, so we have had it in operation for almost 2 years. It's at a filling station in Norway. It's a Heinor Lillestrøm station where you have a complete infrastructure for vehicle refueling, and it's actually a R&D center for testing and demonstrating all kinds of different hydrogen technologies. And there we are the first stage of compression, so the filling station actually can deliver 700 bar hydrogen. So we take the hydrogen from the electrolyzers at 10 bars, and we increase the pressure to 200 bars, and then there's a second stage compressor, a normal compressor that takes it to 800 bars. So in this case, we're only the first stage. We've also built a smaller one, which is a 5 cubic meter compressor. This was done in a European project in cooperation with Highgear, IFE Air Products. And in that case, we were taking hydrogen from a reformer, using natural gas, and we compressed the hydrogen up to 210 bars, 5 cubic meters an hour. If we explain this in a little bit more technical details, and if you look at the graph to the left, it actually works in a way that you have low pressure hydrogen coming in, and we're cooling the unit at the same time as the low pressure hydrogen is coming in. Then we apply heating, so in a sense the tube is closed, all the valves are closed while we're heating up the cylinder. Then we continue to heat the cylinder but open the valves, and then we get high pressure hydrogen coming out. And then we start cooling the cylinder again to actually then absorb hydrogen again. So that's the cycle that the picture to the left actually shows you. So it's not a very complicated system. And this is a schematic picture. This is actually off the two-stage compressor. So off the HiMAC 5, the 5 cubic meter one. So you can see how it's interconnected. So there's always one cylinder being cooled, one cylinder is being heated, one cylinder is absorbing, one cylinder is deabsorbing. So this has to have, so that we have a continuous flow, we have to have 6 cylinders. And you can actually see when we are applying the temperature, you can see how each cylinder is the temperature is being raised. And then after the temperature is being raised, you can see the release of hydrogen continuously coming from different cylinders at different times. So it's a very steady flow of hydrogen coming out. And in this case, we used 140 degrees or almost 140 degrees hot fluid for the heating. So this gives you a quite high ratio of compression. And to see this in a little bit different picture, you can see how the two stages are working. So we are getting in hydrogen at about 6 bars. And in the first stage, we raise it to a little bit above 50 bars. And then in the second stage, we go to 210 bars. So it's the cold fluid is actually around 20 degrees. So in a sense, if we would have access to colder water, you increase the delta T and you increase the ratio of each stage. And we're using 140 degrees. Actually, in this case, we're using oil. So you can see that the 6 bars coming in raised to about 50, and then 210 bars coming out continuously. So this is actually the cycle of how the flow of hydrogen is actually coming out from the compressor. And this shows how steady the flow has been. You can see that our testing at our testing facilities, we've seen a very good steady flow of hydrogen at 210 bars, and so the inlet pressure is somewhere between 5 and 8 and goes up to 210. We have now operated the units for over 1,000 hours. Of course, we have done some optimization of the system and looked into all applications. We're going through cost reductions and all kinds of different applications. So actually we are quite happy with how we have moved forward and seeing that the technology is actually performing just as we expected. And these small adjustments we have had to make are very insignificant. So if you look at who we are in a sense targeting, we're looking quite a lot to industrial application, of course, with the potential of utilizing waste heat. And then of course you have almost no energy consumption whatsoever, so almost zero use of electricity. We could also be first stage compression at filling stations, specifically the first ones being built now, which are all of them quite small, producing about 5, 10, 15 cubic meters an hour, and we could easily be the first stage of that. Bottling of hydrogen is a very interesting application for the technology. Of course, again, where waste heat would be available, or if you would have access to geothermal, you would have a very low operating cost. And then we're also working with partners in Canada and the Faroe Islands and some other places of storing hydrogen from wind applications. So in those places you have remote islands or remote societies where actually they have wind farms providing electricity for a closed island, and there actually we could compress the hydrogen to store some of the energy which is coming from the wind when we have too little wind, or actually in some places the main reason for the wind to stop is, or wind power to stop, is too high wind. And then of course in reformation of hydrogen or reformers, there's a lot of waste heat available, so that's why we did a project with HyGear to utilize the heat from the reforming process directly into the metal hydride processing. And of course there could be other applications which we are examining. So we are quite happy with our proof of concept operation. As I said before, we have over 1,000 hours of operation, and that has been completed very successfully. We are of course doing quite a bit of R&D activities with our partners. We work quite a bit with a company called Aquagas in Sweden, and they are actually the constructor of the compressor. So we have patented a part of the technology, so it's protected. We have already quite interesting partnerships in place, but we are interested to expand our partnership. So we can say that we are ready for market deliveries. We are now negotiating for sales of a handful of compressors to different applications, and we are convinced that this is a unique way of providing compression of hydrogen. And you're all welcome to visit us at booth B60, which is kind of a Norwegian booth where we have an assembly of the key Norwegian companies. And we would like to thank our main investors, which is Norsk Innovasjonskapital. They have been a very strong supporter of our activities, both in the R&D and also in the marketing. Thank you very much for your attention.
Thank you very much also from my side for this very interesting presentation. Are there any questions from the audience at this time?
Hi, I'm Justin from Mfield. Just a quick question about the energy efficiency and compare with traditional compressing method.
As I said, if you have access to waste heat or a heat source, the energy we utilize is almost zero. There's almost none electric power. We only have to move a handful of valves. Of course, if you need to heat up a fluid, with electricity or with any other source, then the efficiency is of course lower than a conventional compressor. That's why all our niche markets and our key target customers is where you have access either to waste heat, geothermal source, or any kind of heat source, or from a reformer.
Thank you. Are there any other questions? Okay, then thank you very much for the presentation. Thank you for your questions, and all your other questions can be taken to the booth at B60.
Yeah.
Thank you very much.
Thank you.
Our next topic will be forklift trucks. And I've seen there are some forklift trucks even here on the fair. Recommendations for the market introduction. This is going to be very interesting. Hydrogen has made it to the market. We are going to produce serial cars this year. Toyota has already moved forward. Daimler is going to serial production 2017. So let's see how we can continue with our topic for the whole day, stationary and off-grid fuel cell applications. That will be only in a few minutes' time.